Hi, I'm class 1 Officer, secondary 1 from NS High School. Right now here, we're still going on with our ordinary differential equations, or also known as ODE. So right now here, we're still at the operators method. Well, in this case for the operators method here, what do we have? You look at this example here. Well, can you find a pattern out of this example? Well, of course, you'll say the power of x is always the same as the order of differentiation. Well, that is right. And in fact, it applies to each term. Okay, so that's what we're going to have here. So first of all, for this type of example, we will need to let x be e to the power of t. Well, if you actually want to know why the whole process is so, well, just go back to those videos to watch them. Okay, well, let me just tell you one of them. Why? Well, first derivative, then you will still get itself. So first derivative, then still get itself. Yeah, that's it. So that's what we're going to have here. So for this first part, well, at the center of the substitution, we can also change them into the operator's form. Let's say the first. So that you have 4. That means you get d subtract 3 times d subtract 2 times d subtract 1, then d. But beware, we can also take out this y at the same time. Then after that here, you also have to be aware that these coefficients in front, you cannot miss them out. And at the same time, this x will also have to be changed into e to the power of t. So that will be the form that we're having right now here. So first of all, we need to find what this part is. So in this part, that's the first thing that we'll have. D power of 4 subtract 6 d power of 3 add 11 d squared subtract 6d. So that's what we have. Then for the next parts, well, those will be much simpler. Like for example here, at first it is a d squared, extra d, d cubed. Then here we will subtract 3d. So then it becomes time to subtract 12d squared. Okay? Then after that, 2d times 4. Get 8. Okay. The next will be for more simpler. Then after that, you're going to have to try to change it into another form. Okay, so this is what we will have. After we could try to combine them together, well, at least some of them. So cube these two. Square than those without these. And of course, the last is constant. So this is what we will get after that. Then we're just going to use the factor theorem. In this time, the factor theorem, we just suggest F1, then D. It will be this part. Then after that, then for this part, wait a second. This part is a half. Then from here, what you get is 1 subtract 2, add 3 over 4, then you add half, then you subtract 1 over 4. Then from here at least, from here you get a 0. Since here negative 1, here you just get 1. Okay, so that is what you have here. This is a 0. There is one part is a d subtract 1. And then when you get a d subtract 1, so what you'll use right now here is the long division. Okay, so what we got here is right, but this part above we'll have to use the factor theorem again. So this is the part where we need to use factor theorem. Then after that, we just start it with 1. Well, perhaps we just try it again. And these two cancel out, these two cancel out. You get a 0 again. So that means here, you can have another d subtract 1. Then here, whereas you don't have anything, but here you need subtract 1 over 4. Then this is what you get. So first part, this is d subtract 1, then square. Then after that, 2 times d subtract half. Then d add half. Okay, that's it, y, and this will be equal to e to the power of t. So then, afterwards, y, so just divide all these to the other side. And let's check whether there's anything peculiar about this. Well, wait. There's something strange. This is subtract 1. That means inside, if we use the integrating factor inside, that means 0 times the e to the power negative t. And then because of this, that means at last that power will be a t. That means here we actually had a multiplicity of these roots. So we have a multiplicity of these roots. That means you have to put it at last, then we use it. If not, we will have other like integral by parts if we have used that first. So in this part, we're going to have these two parts first, then start on this. Okay. Wait, here is a 3 over 2. That means we'll have an extra 2 over 3 at the front. So when you times them together, you get 2 over 3 times d subtract 1, then square. Okay, so at this point you have a half, that means you get 4 over whatever is there. Okay, let me just show you. This is the part that I'm saying about. Here inside here, you get 1. That means you get a t. So when you get a t, then you use the next, what you'll get. So right now here, you're actually just integrating this t. So at this part, it will still become 2 over 3, but then you get a t squared, then e to the power of t. So that's what you will get. So then change it back to x. You get 2 over 3, so t squared. T is ln x. So it will be ln x and squared. Then e to the power of t, that will be an x. So that's what we have here. Next part, we're going to verify this. So for this part of the verification, here we already have y. Verify the first derivative of y. So in this part, the first derivative of y, beware of that. We'll need to use the product rule. So we can go against this x first, which will get 2 over 3, then ln x, then square. Then afterwards, you add 4 over 3. So if you use this, yes, extra 2, you still get a ln x. But then after that, ln x differentiate, you get 1 over x, 1 over x, simplify with the x. Okay, so this is your first derivative of y. Then it will become your second derivative, which you need to find afterwards. So the second derivative of y that you need here, from this first part, 4 over 3 ln x over x. After here you add 4 over 3x. So this is the part that you will have. Then third derivative. So in this part, 4 over 3 ln x, well, we're just taking it as a product rule here. Ln x, you get 1 over x squared from here. After x, you get negative 4 over 3 ln x over x squared. Then you subtract 4 over 3 x squared. So what you'll get in the last part will be a negative 4 over 3 ln x over x squared. So that's what you get here. And last but not least, here will be the fourth derivative. Fourth derivative. Negative 4 over 3 ln. For ln, here you'll get x cubed. Then after that, here will be a positive. So, seems like you get extra 2. Positive 8 over 3 ln x over x cubed. So that is all that you have. Let's start from here. So then, 8 over 3 ln x. Hey, it times the x to the power of 4. You get x. Until this part, you shouldn't be like giving up on like how come all these denominators, they all look very different. How can you get all of them the same at last? Well, beware, here you have times x to the power 4, 3, 2, 1, 0. That's how it may just all come together. Well, beware. Here you have the times extra 4 also. So when times extra 4, 16. 16 over 3, then times x cubed, you get an x. After here will be for the second derivative part. Okay, so far we have done until the second derivative, so let's just try again. So, in the first part is fourth derivative. So, fourth derivative here, we put this part first, then here behind. Then for the third derivative, wait, this part is x. This part should be an x here. Okay. Then after that, we had this third derivative. So this third derivative, we times 4 and x cubed. So yes, here. Then afterwards, this square. So this square, you times the extra 7 over 4. So these 4s will all be cancelled. It will be replaced by 7s. Okay. Then next will be on with our first derivative. So first derivative, you need to times extra 1 over 4. After that, you subtract 1 over 4 times this y. So, subtract 1 over 6. So, that means it will be this part. Okay, so that's what you will have over here. So this is what you have. Okay. Then let's see what you'll get later. X ln x, x ln x, x ln x, x ln x. 8 subtract 16 is a negative 8. Negative 8, negative 1, 1. Okay. Cancel out. Then negative 4 over 3x. 7 over 3x. Okay, you get x here. Then the two remaining parts also cancel out. So you get x here and x here. That means this part will be right. Okay, so that's all they are going to have in this lesson. So that means what we get here is right. But just a note here. In this time, we are only finding for, well, we have a homogeneous solution, right? We're finding for the other one. Okay, so that's what's all for this lesson. So I'm just going to end this lesson here. And if you like our videos, don't forget to subscribe to our channel. Thank you for your watching.